Welcome to our live training session. We're going to learn how to calibrate and tune our Honda Civic Si using a Link G4x plug-and-play system. Let's jump into some details about our vehicle. Now, the vehicle has been swapped with a K24 engine that's been rebuilt. It has 12.5:1 compression pistons, aftermarket rods, upgraded valve train, OEM cams, a 50-degree VTC gear, and an upgraded Type S oil pump. Now, on the induction side of the engine, we have Kinsler 64mm individual throttle bodies. On the fuel system side of things, we have RDX 410cc injectors and an upgraded in-tank fuel pump. On the exhaust side of things, we have a header back exhaust. Now, we also have, in addition to this, a fuel pressure sensor and an AM X series wideband that we've tied into our Link system. We're going to learn how to calibrate and tune this using an alpha end strategy. Without further wait, let's jump in so we can check this out. Welcome to our live training session. We're going to be taking a look in this tutorial at how to create a base map, specifically setting up our inputs and outputs and background details so that the Link's going to understand what type of engine we're controlling and making sure all of our sensor detail and output control, such as our fuel pump or the cooling fan output, is set and configured correctly so that we're going to have a proper running engine and vehicle control once we get the engine to fire up in a future tutorial. Let's jump in here and take a look at some of the basic details we need to get started with here and making sure we have everything accounted for in our input-output setup for our vehicle. Now, the first thing we're going to find here is that I have the PC Link software open on my laptop screen right here. I do not have a file loaded into the screen or into the software right now. I need to go ahead and pick a file to start off with to begin our calibration process. That's going to lead us into the directory of base maps from Link, so we can choose one for this plug-and-play application. So I'm running a plug-and-play Link DC5 application. This is going to be what you would typically find for a Honda K series engine. Running a factory harness. This plugs right in. It controls all of the outputs and inputs on a factory harness. I have an EP3 chassis, so this is going to be what's suitable for this vehicle. Let's jump in here and take a look at setting up our base map based around knowing we have a plug-and-play DC file. So we're going to go up here to File, and we're going to go to Open. That's going to bring us into this directory here. So it's going to be the C drive, Link G4x, PC Link G4x, and then Base Maps subfolder. And here we're going to find a ton of different options to choose from. We're going to go down our list here, and we're going to find that we have this option here, Honda Integra Type R DC5 G4x Extreme Plugin. That's the exact board or box that I'm running here. That's what I'm going to choose for my base file. Let's go ahead and select that and Open, and that's going to bring it into my software. Now, I'm sitting in my vehicle right now with the ignition key off. I do have the USB cable plugged into my laptop, but I'm in what's known as an offline state. So I haven't synced my laptop to the Link, and we're going to be building our base map in the offline mode. We can actually see up the top here, we haven't established any communication. This is normally going to be green and showing us the communication speed. This is showing searching right now, so it hasn't found anything. That's okay. Again, we can do the base map creation process offline. This is going to be the situation you're going to likely find yourself in. You're sitting in your house watching the tutorial, sitting on your couch and at your kitchen table. You do not need to be in the vehicle, tied to the vehicle to do a base map creation. So let's jump in here and take a look at how to do this in the offline state. Now, the very first thing that we need to concern ourselves with is going to be going over here into our Basics tab. The layout that I'm working with here is supplied in the training course library. In fact, in the training course packet or folder, you'll be able to go ahead and open up this specific layout I'm working with. It really saves a considerable amount of time when you're editing and working within your PC Link software. So this layout, again, is available. You can open up the layout. That's going to be found here under Layout at the top, and then Load Layout. Load the layout from the course folder. Again, that's going to give you the exact look what I have on my screen right now, so you can follow along building your base map. So what I'm going to do right now is go over here to Basics. This is what we want to start off with. What we're really going to be focusing on for this tutorial is going into the basics, cam crank, analog inputs, digital inputs, and outputs. Now, we do have a lot of other tables. We're not going to touch on those in this tutorial. Again, we're just going to be focusing on setting up an inputs, outputs, and basic sensor configuration details. This is going to be the one part of the base map creation process. All the other tables that have to be set up and configured will be something else we touch in the next tutorial. So let's jump in here and take a look at how we can set this up and looking at all the different options we have for configuration. So the first thing we're going to find here is under the configuration, we have cylinders 4, engine type 4-stroke, connection speed fast, custom TDC, we'll leave that off, serial port 1 and serial port 2 mode. We can see that's set to a Honda Integra DC5. Now, if you're on a swap vehicle, so you're an EG, EF, EK or whatever you're going to be putting a K series in, this doesn't necessarily matter. But when you're dealing with a DC5 or an EP3 chassis, the native chassis for a K series engine, this output is critical to drive the dash. So the multiplexer for the coolant temp gauge and the immobilizer light need to be functional, and the outputs here should allow that to function just as OEM. So you don't want to go ahead and upload one of the other base files that they have in the directory that's more of a generic file. You want to go and work with something more specific here, which gives you the option to use this 0 port 1 or 2 mode. So this file is unique to this plug-and-play G4X box for the DC5 EP3. Okay, so the next thing we have here is a firing order table. 1342 is the firing order, pretty straightforward there. If we take a look under fuel main, injection mode, we are sequential injection from Honda with the factory wiring, and that's what we're sticking to here. That's going to be firing 1 injector per engine cycle per cylinder. Fuel equation mode. Now this is going to be some options we can choose from. We have traditional model, model multi-fuel. If we're going to be doing a flex fuel based tune and we want to have volumetric efficiency as the strategy in order to tune and calibrate our engine, we would choose the model multi-fuel. Model is going to be if we don't have a flex fuel plan or a flex fuel sensor wired in, we have no plans to do a flex fuel based tune, we'd be choosing the modeled option. Traditional switches us over to a injection time based strategy, so it's not going to use math essentially to figure out what the injector pulse width is going to be. It really dumbs down the tuning process. Now it works just fine. I prefer to use the model mode because it just gives you more consistency going from car to car rather than the traditional. It's almost unique car to car as you're going through and setting up the variables. So I like to use the model mode. I am not doing flex fuel in this vehicle, even though I do have a flex fuel sensor installed in the fuel system on the feed line. This is a returnless fuel system. I'm going to go ahead and still choose model. I'm not going to set up anything with flex fuel on the vehicle for this tutorial. The last live training tutorial that we were taking a look at with this specific vehicle, one had normal bolt-ons and it did not have individual throttle bodies. We did that flex fuel based tune and I showed that process. It would be the exact same thing we're finding right here. It's just that I'm not going to include that for the tutorial. So I'm just going to include model, and I am on pure petrol fuel right now, or 10% blended petrol fuel, but we'll find that I do not need to have the model multi-fuel because I don't plan on putting ethanol in the fuel system. So I'm going to grab the model mode, which is the traditional airflow strategy that we would work with the link. Again, traditional is the other option. It dumbs down. The math is essentially deleted out of the link, so we're not going to be modeling airflow and the fuel mass and the injector pulse width that's going to come from that equation. We've talked about pretty heavily in the training course and other live training tutorials. So model is what I prefer to work with here. Now the equation load source, this is something that's going to be unique to individual throttle bodies. Because these are huge individual throttle bodies, they're 64 millimeter Kinsler ITBs. If I give a little bit of throttle input, I essentially go from pulling reasonable engine vacuum to almost atmospheric pressure from the map sensor reading. What this is going to do is make it near impossible to calibrate and tune this vehicle using a map sensor as the load input, or MGP as the load input to my main fueling table. We have to go and calibrate things based on throttle position. Now, that in itself, just calibrating on throttle position, we typically would want to have load equals map as the option here. However, when you have extremely large camshafts that pull very little or no vacuum, and or you have a huge throttle body or individual throttle bodies where you have an extreme unlinear relationship between throttle angle and map pressure, exactly what I have here, I'm going to have to change my equation load source. So we're going to be moving it from load equals map, and what this assumes is that if your map sensor pressure doubles, your fueling should double. We're going to be switching this over here into load equals baro pressure. When we choose this option, we give a little bit more stable input for that pressure registration within our airflow model, and this is going to not account for manifold pressure doubling and fuel doubling. This is going to be assuming that we're essentially going to be having, again, ITBs. This is specifically with the situation we're working with here. We have an unstable map signal, or almost unusable map signal. We have to have something as a input into our air mass model. The baro pressure is going to be what's used. Throttle position is what we index our fueling table by to create what's known as an alpha N strategy. And this is very specific, again, to individual throttle bodies. Now, if I had small individual throttle bodies, let's say I had 40 millimeter throttle bodies,
the relationship between my throttle angle and map pressure, so if I give a little bit of throttle input, I wouldn't immediately jump to atmospheric pressure. I would find that I'd have a little bit more linearity there. In that situation, I would use load equals map. But again, big individual throttle bodies and or big cams or a combination of both does require you to have a relatively stable air mass registration, and we can do that based on using the baropressure sensor. This essentially will allow us to vary elevation with an alpha end strategy and account for any movement in that elevation in our fueling calculations. So this is just going to improve things in a true alpha end strategy, again with an unstable map sensor signal. So that's what I'm going to choose right now. Now the engine capacity is important. This tells the link what the display.
Thanks for checking out our teaser clip. If you want to see the rest of this video and more than 500 hours of current EFI training we have to offer, make sure you click right here. If you want to go and check out more teaser clips from this training course, click here, and you don't want to miss any of the videos we're going to be releasing on this channel, so make sure you subscribe and click here. Thanks for watching, and I'll see you guys later.